So, welcome to the lecture series on regression. In this lecture, I will be discussing about the regression lines. We have already seen about the basic concept of regression, about regression coefficient, and here we will be trying to get the idea of regression lines, how regression can be used for prediction of a particular variable, and then lastly, what is the difference between regression and correlation coefficients. So first of all, I will be starting with regression line. So what is regression line? So regression line, it is a line of regression line is a graphic line. It can be presented in the form of graph that gives the best estimate of one variable for any given value of other variable. So this will regression line will establish a relationship between two variable in terms of values. What will be the value of one variable if another variable is this much? So that thing, if we are presenting in the form of graph, then such line is called as regression line. The regression line of y on x help us in estimating the value of y for any given value of x and vice versa. So with the help of regression line, we will be able to find the value of y for any given value of x. So here we will be seeing examples of regression lines. So these are the regression line. Here you can see, if you see carefully here, the correlation coefficient is 1. So if correlation coefficient is positive 1, that means 1, and that too it is positive. So in that case, if you see carefully regression line, it will be going upward from left to right. It will be going upward from left to right, and both the lines, that is x and y, both x and y lines will be coinciding upon each other. So this is the regression line when correlation coefficient is 1. Another case will be if the correlation coefficient is -1. So same thing here again, both line will coincide, but when you will proceed from left to right, the lines will be going downward. From upward, it will be going downward. So this is the difference between the regression line when the correlation is positive 1 and when the correlation is negative 1. Now, suppose the correlation is not perfect 1. That is, correlation is not 1, but the correlation is very high. Correlation coefficient is very high. So in that case, you will see two lines will be close to each other. They will be crossing each other, but they will be close to each other. The distance between these two lines will be very small. Whereas if the correlation coefficient is low, in that case the lines will be away from each other. That means these two lines are apart from each other. So if you will see the position of both the lines, x line and y lines, that means the position of regression line will say how much correlation is in between the two variables. Similarly, if you will see another condition, if correlation is 0, there is no correlation at all. So in that case, both the lines will be cutting each other at perpendicular. So both the lines are perpendicular to each other. So in that case, when the lines are perpendicular to each other, there will be no correlation. So these are about the regression lines. Now another points about the regression lines, we can illustrate the linear relationship between two variables on the basis of value of regression coefficient. So what we have seen earlier, it was on the basis of correlation coefficient. Now if you want to learn this regression line in terms of regression coefficient, here you can see when b is positive, that means when b is greater than 0. So what will happen? Again, in the regression line, it will be it will be increasing. That means it will be going upward from left to right. on the reverse side, if the if the sorry, it is written plus but it is minus. When b is negative, that means कि b is second condition. You can see if b is less than 0, then you can see the decrease in x lead to decrease in y. If x is decreasing, so y will also decrease. If x is decreasing, y will also decrease. There will be negative linear relationship. That means the line will be decreasing, or it will be going downward from left to right. If you move left to right, then in case of negative correlation coefficient, decrease in x will lead to decrease in y, whereas in case of positive, when b is positive, increase in x lead to increase in y. So this is how the regression line can be explained in terms of regression coefficients. Now the prediction function of regression. So it is very interesting, and the major function of regression is to predict, that is prediction of one variable for a given value of other variable. So many a times there will be situation will arise in your experiment or in the research that you will conduct, that for a particular value of x you want to know what will be the value of y, or you will be observing the values of x and y, and after observing the values you will try to know for future x value what will be the y value. If you are having only x value, what will be the y value. So we can predict the value of dependent variable. For a given value of independent variable, and the equation should be y hat, this cap symbol, this is the symbol of cap, or you can say it hat. So y cap is equal to, or y hat is equal to a plus byx into x. So if you see this equation carefully, it is similar to the equation of straight line equation, where in a straight line we have read that y is equal to mx plus c. Here similarly y is equal to bx plus a, where a is intercept. Here you can see the y cap is predicted value or estimated value. So this y cap or y hat is a predicted value of y for a given value of x. For a given value of x, what will be the y? That is y hat. And a is intercept. Why a is intercept? Intercept means that is the value of y when x is 0. When x is 0, then also there will be some value for y. So that gap is known as intercept. This you know in case of straight line equation also, y is equal to mx plus c, where c was intercept. So which is concluded as a is equal to y bar minus byx into x bar. So this a intercept is the difference between y and x. Now what is x? X is the known value of x. X is that known value of x for which y is to be estimated. So this x is the known value of x. X is having some value which is known, and with this value we will be estimating the y. Thus you can see in the above equation, a gives the value of y for x is equal to 0. So when x, I have already discussed that when x is equal to 0, what will be the a? A will be the value of y. When x is 0, y is equal to a, that is intercept. So that will be difference between x and y. And byx gives the change in y due to change in 1 unit of x. So what is byx? Byx already we have studied in the last lecture that byx is the regression coefficient. What is the regression coefficient? What will be the change in y when we are changing x by 1 unit? So here you can say this equation can be presented in this form: y hat is equal to dependent variable, then A is intercept. B, in a straight line equation it was m. Here the m is converted into b. B, that is regression coefficient. It is representing slope, and x is the independent variable. So hopefully this prediction function of regression is clear to you. It is totally based on the straight line equation, and it is the relationship between dependent and independent variable, and we are quantifying the relationship with the help of regression coefficient, that is b by x, and a is the intercept. Now what is the coefficient of determination? Another term is the coefficient of determination. So this coefficient of determination can be explained in terms of correlation coefficient and also in terms of regression coefficient. So what it is telling, the square of the simple correlation coefficient. So simple correlation coefficient, we know it is represented by r. So the correlation coefficient, square of the correlation coefficient, that is r square, is known as coefficient of determination. So we'll see what is coefficient of determination. So what it measures, why coefficient of determination is important, because it measures the amount of variation. It measures the amount of variation in one variable that is explained by another variable. So what is the amount of variation? That means suppose a dependent variable is y. So what amount of variation in y is due to another variable, that is x, that is independent variable. So what amount of variation which is present in y is due to x, that is determined by coefficient of determination. That is why it is called as coefficient of determination. In a particular variable, how much percentage is contributed by another variable. So that is called as coefficient of determination. In other words, it is defined as the ratio of explained variation to the total variation. So suppose total variation in y is total variation, this total variation. So how much in y is due to explained variation? Explained variation means variation due to x, and total variation means so how much variation is there in y. So the ratio of explained variation to total variation is known as coefficient of determination. Here one example you see, if r, that is correlation coefficient, is 0.8, so what will be the r square? It will be 0.64. That means 64% of variation, that means 64% of variation in dependent variable, that is y, has been explained by the independent variable, that is x. So this is 64% independent variable is due to x, and this 64% of the variation in dependent variable is due to independent variable, that is x, and remaining 30% is not explained. So that may be due to certain other variables which we have not taken. So that is why this 34% is unexplained. So that is why coefficient of determination is explained variation divided by total variation. So out of total variation of 100%, 64% is getting explained by your independent variable. So this 34%, 36% you are not able to explain it. So the thing that is not being explained, we are generally putting it into the error, or also called as residual. We will see in the later slides. See, in an ideal situation, when all the points lie exactly on the line, in an ideal situation, suppose there is one ideal situation when all the points lie exactly on the regression line, on a line. That means the x variable is able to explain all the variables, all the variation present in y. That means the variation present in dependent variable is getting explained fully by independent variable. So that means there is no error. That means you are able to explain 100% of the variation. So in that case, and the y value are completely explained by linear dependence on x. in order to that in that case, that means there is no error, but it is in in practice we will not get any situation where a particular variable is getting is explaining the 100% of the variation in the dependent variable. So in order for straight line model that is regression model to be considered as providing a good fit, so good fit of the data, the sum of a square due to linear regression should comprise a major portion of summation y square. So what it is trying to tell, sum of a square due to regression, that means sum of a square due to the independent variable should be a major portion. Suppose you are taking a dependent variable milk yield, and your consideration is that if cow is exercising, then milk production is increasing substantially. So this is your hypothesis, but in practice, the exercise may be increasing milk production by 1% or 0.5% or even lesser than that, because many other factors are controlling the milk production, maybe feed, maybe environment, or maybe anything else. So this exercise as independent variable is a very poor predictor for milk yield. So in that case, majority of the portion will not be getting explained with the help of independent variable, that is exercise. So it should not be there. If a model has to be a good model, you have to take independent variable which is relevant. That means y square, it should explain, y square should be explained substantially by the help of independent variable, that is x square. Now, in an ideal situation in which all points lie on the line, sum of a square due to error, I have already told you, when there is a straight line, that means all the variables are getting explained, all the variation is getting explained by the independent variable. So in that case, there will be no error. There will not be any error. So sum of a square due to residual means error. Sum of a square due to error also you can say is 0. So summation y square, that means variation in independent variable, that is variation in variable y, is completely explained by the fact that x value vary in the experiment. So variation in y is completely getting explained with the help of x value. That is, the linear relationship between x and y is solely responsible for variability in the y. So with this you can interpret that y is solely depending on x. Suppose you are taking milk yield and feed consumption. So if feed consumption is explaining total variation of milk yield, that means the milk yield is solely depending on the feed consumption. Now, the coefficient of determination R square is represented by capital R square. That you have to remember. That is by convention we are representing it by capital R square. It is often used as a measure of the correctness of model. So I have told you this: if a particular variable is able to explain the variation independent variable, so how much variation is getting explained by independent variable? If a particular measure is measuring that, that means this particular measure is able to explain the correctness of model, whether model is a good or bad. So this coefficient of determination is measuring the correctness of model. Similarly, we have already studied a good model is model in which the regression sum of a square is close to total sum of a square. Regression sum of a square means sum of a square due to independent variable. Sum of a square due to independent variable, that means sum of a square due to x. It should be almost equal to sum of a square due to total sum of a square. That means sum of a square means variance. We will see when we will studying ANOVA, we will see that sum of a square is variance. So variance due to regression, it should be almost equal to or equal to total variance. Then only you can say that if this particular model is a very good model, because there is no scope of error. All the things is getting explained by the independent variable. On the other hand, if their model is bad, in such case, the residual sum of a square, that is error sum of a square is close to the total sum of a square. If a model will be bad, if your independent variable will not be explaining any variation present in the dependent variable. That means sum of a square due to residual will be equal to sum of a square due to total, or it will be close to sum of square due to total. Any error, all the variation is due to error. Your independent variable was not able to explain the variation present in the model or present in the dependent variable. Now, the coefficient of determination represents the proportion of total variability explained by the model. So this can also be r square is equal to sum of square due to regression, that is sum of square due to independent variable divided by sum of square due to total variable. Sum of square due to total, that is sum of square means variation in that particular dependent variable. So the coefficient of determination is always expressed in percentage, where it varies from 0 to 100%. So the formula for r square will be r square is equal to sum of square due to regression divided by sum of square due to total into 100. So this is very important formula. You have to remember. We have already understood why this formula is like this. Why r square is equal to sum of square due to regression divided by sum of square due to total. Because this coefficient of determination is the ratio of variation explained by a particular independent variable divided by total variation present in the model. Since an increase in the regression sum of a square indicate increase in regression sum of square, if sum of a square due to regression is increasing, that means the model is going to explain many of the things. That means model is good model. Indicates a decline in error. So if sum of a square due to regression will increase, the sum of a square due to regression will increase, that means error will decrease. And the coefficient of determination can also be obtained as, so in that case r square can also be obtained as r square is equal to 1 minus sum of square due to regression divided by sum of square due to total. So this is about the coefficient of determination. Now the strength of linear relationship. Now, you see, to arrive a measure of the adequacy of a straight line model in linear regression, measure of adequacy means correctness of the model, we examine how much variation in the response variable is explained by fitting the regression line. Same thing we have already discussed. We can partition the observed yi means dependent variable, as consisting of the following two components. So variation in dependent variable can be of two components. What will be the two components? First one is explained by the linear relation, explained by the model that you have applied, and second one is the error, that is residual. So one which is not getting explained by the model is coming into the error. So y, that is variation in dependent variable, will be of two components. First is explained by linear relationship, and another is the error or residual, which is not getting explained by the linear relationship. Now the last portion, what is the difference between regression and correlation coefficient? This will be important question for your examination, that means for annual board examination, and even in your internal examination it can be asked. So what is the difference between correlation coefficient and regression coefficient? The most of the things we have already studied, so nothing new I have to tell. The first difference, measures degree of relationship but not the cause and effect relationship. I have already told that correlation coefficient is not a cause effect relationship. It measures the degree of relationship, whereas this regression coefficient is a cause effect relationship, and it establishes a functional relationship. It establishes a formula. It will establish an equation where you will be putting some value and you will getting the value. So second one, the correlation coefficient is used for testing and verifying the relationship. So with the help of correlation coefficient, you will test and verify whether a relationship is positive or negative. Whereas regression coefficient, beside verification, it will predict. It will predict the dependent variable with the help of independent variable. We have already seen. Now, the correlation coefficient ranges from -1 to +1. -1 to +1. Whereas regression coefficient will be ranging from, here the symbol is not clear, it is from -infinity to +infinity. That means regression coefficient value can be anything. It will be -infinity to +infinity. Then correlation coefficient, there may be spurious correlation. Spurious correlation means the correlation which is not getting explained. It is due to some other reason. When we are talking about x and y, the relationship between x and y, the relationship, there may be relationship, but it is not due to x and y, but it may be due to certain other factors. But in case of regression coefficient, there will not be any spurious regression. There will not be any spurious regression. Then another important point is that correlation coefficient, it has no unit of measurement. It will not be having any unit of measurement, whereas regression coefficient will take the unit of dependent variable. This is very important point. We have already discussed in the last class. It expressed in the terms of unit of dependent variable. Now this also we have studied. Two correlations are one and same. When we are talking about Rxy and Ryx, correlation between xy or correlation between y and x, these two will be similar, whereas this Bxy and Byx will not be same. It will be same only if standard deviation of x and standard deviation of y are same. So in general, the two regression coefficients, that is Bxy and Byx, will not be equal. Now the last point, independent of change of origin and scale of measurement. So this correlation coefficient is independent of change of origin and scale of measurement, whereas regression coefficient is independent of change of origin, but it is not independent of scale of measurement. So what is change of origin? I have already discussed in change of origin and scale of measurement. I have already discussed when I was telling you about the properties of variance. So you go and refer what is change of origin and what is scale of measurement. Here you have to remember that correlation coefficient is independent of change of origin as well as independent of scale of measurement, whereas regression coefficient is independent of change of origin, but it is depending on scale of measurement. So with this, I have completed about the regression coefficients and the basic concept about the utility of regression for the undergraduate student of veterinary field. So in the next class, I will be discussing about something else. Thank you.